Okay, this problem asks for the convergence of an improper integral. So the question is to determine if the integral from 0 to 1 of e to the x over x squared dx converges or diverges. There's a vertical asymptote at x equals 0, so this is an improper integral. And we're going to show that this integral diverges by using the comparison test. So the key is to notice that e to the x is bigger than or equal to 1 whenever x is bigger than or equal to 0. And so now we can use the comparison test to say that the integral from 0 to 1 of e to the x over x squared dx is bigger than or equal to the integral from 0 to 1 of 1 over x squared dx, because e to the x is bigger than 1. And this integral diverges, which diverges by the p-test, because p is 2 here. If you don't remember the p-test, you can evaluate this directly by a limit and see that it diverges. So this, if you didn't know this is equal to the limit as r goes to 0 from the right, integral from 0 to 1 of 1 over x squared dx. That's the definition of this improper integral. And this is just equal to the limit as r goes to 0 from the right, negative 1 over x evaluated from 0 to 1, which is the limit as r goes to 0 from the right, negative 1 plus 1 over r. And you see that as r goes to 0 from the right, this piece tends to infinity. So this limit does not exist because it tends to infinity. And so this integral is bigger than an integral that diverges to infinity, which means the integral from 0 to 1 of e to the x over x squared dx diverges by the comparison test.